Looks good for me.
Okay. And I'll try to keep the same font size. So let's step inside the bed workshop directory. Over here, we'll have a few files and a few folders. The folder that we'll be interested in right now is the performance image. Later on, we'll move to the other folders with the ROS deployment, and we've got some other performance test outputs that showcase the structure of the outputs that Adrian will present later on. So if you would, let's start with the performance image. There is an already prepared script for you to be used. We'll just need to. So let's just see what exactly this script does. To do so, we can see the contents of the performance image directory in here. As you can see, we've got only the build.sh file. So let's take a look on this file. Let's do cat performance image build.sh. And as you can see now, this script does only three things. It clones the appropriate repository of Apex AI performance tests. Then we'll check out to the desired branch that we will want to use. In our case, this is a Foxy desktop Foxy, and this is a desktop version as far as I remember. And at the end, we'll just build this Docker image, so it will later on appear in our Docker system. Okay, so before we will build this, we have to do one thing, which is make this build.sh file and executable. To do so, let's use the following command: sudo chmod +x, and we will specify the path for the build script, which is the performance test / build.sh. Have in mind that I am doing this from the main directory of the repository, so you'll have to specify the performance image directory. Let's do this. We will be asked for the root password, which is same as the username ROS, and now we should see that the file is marked as an executable. As you can see, it has this green color right now. So now let's call this with / performance image build.sh. As you can see, this script is cloning the appropriate appropriate repository, is checking out the branch, and now we can see the Docker pulling the needed layers for the to complete the process of building this image. This may take a while. As you can see, we've got more than 600 megabytes to download. So the speed of your download will be based on your internet speed connection that you have. But don't worry if your download won't finish. Later on, we'll move to the other part, and that will not exactly require this. That will not exactly use this image for the purposes that, because we'll not use this image because we are time constrained, and there are some additional steps that will have to be taken to exactly use this image in a microcase environment. Later on, we'll send the link on how to exactly do those steps. So you'll be able to use your own the image that you'll build, or if you want to modify it, you'll be able to build it and export it and import it to the microcase environment, which is a minimal Kubernetes system installed on this machine that we are using right now. Let's give it a second for now. And meanwhile, do you have any questions for this part?
Not yet any question.
Okay, then. So let's. Okay, so let's give it a moment, and I think that in a second we should be fine. Oh, okay. So so what happened right now is we have pulled the desired image, and the rest of the image is being built. Right now, we can see that to build this image, we will be updating all the ROS2 packages needed for this system, and some additional components will be installed. So let's give it a second for now. We should see it moving in a moment. Oh yes, as Aaron has sent us a link in the chat, if you would like to see the more information about what the 5G-ERA project is about, this is to the people that are not in the 5G-ERA consortium, you can use the link in the chat, which is www.5gera.eu, and on this website you will get much more detailed information of what the whole project is all about. Okay, this update is taking a bit of time. Okay, I think that we can go back to this part in a moment, and right now I'll just quickly explain what we'll be doing in the next step, which is the deployment of the ROS2 application inside of the Kubernetes. So the most difficult part about the deployment of the ROS2 applications inside of the Kubernetes is the network. We solve this by adding the additional network card to all the pods that are inside of the Kubernetes. But why actually we have to do so? You see, the ROS2 applications operate mostly on the multicast requests, which are unfortunately not supported by default by most of the Kubernetes implementations. To do so, this virtual machine that we are using has installed microcase, which is the minimal installation of the Kubernetes, with an additional module installed, which is named Multus. It will allow us to define the additional network card for the ROS2 applications. The containers that will have the ROS2 applications inside them, and the multicast communication will go through this second network card, which is linked with the host system of this Kubernetes instance. Okay, so let me show you a second screen. Where am I? Okay, so in the second terminal, I will open the embed workshop folder with the repository once again, and now we'll move to the ROS2 deployment folder. As you can see over here, we've got 3 files. The first one is the deployment of the listener. Second one is the configuration of the Multus networking, and the third one is a Docker. We are using the really trivial example of the Docker and the listener in here, just to showcase how we have to deploy those applications. But also, you may ask, why are we actually doing this? Why do we want to deploy the already working ROS2 applications inside of the Kubernetes? Our answer is, so we can actually use the capabilities of the robot in a distributed and containerized environment that will allow us to scale those applications if needed, that will allow us to take the workload of the robot if we can, so the robot can work long, for example, can work longer or can focus on other tasks. Just give me a second. Oh, as we can see, it's still processing. I don't know why, but okay. So what we'll have to do in this case to configure the Kubernetes environment. Let's take a look on the multus config YAML. I'll use the Vim for this, and so I'm using command Vim and then specifying the file name that I want to edit, which is the multusconfig.yaml. If you want to use your other editor, just go ahead and use the other one. Oh, okay. As you can see, I don't have Vim installed in here, so I'll just quickly install it with sudo apt install Vim. Visuals. Should be fine right now. It's working a bit slowly. Okay, we're there. So let's jump into edit. As you can see, this YAML file is created directly to be compatible with the additional network interfaces inside of the Kubernetes. As you can see, we've got the API version specified, which says what type of the file it is for the Kubernetes. We specify the kind of the file that we want to present in here, which is the network attachment definition. Metadata for this, we just need to specify the name. And the most crucial part of this is the specs. There are only two things that we need to configure in here. The first one is the master, which contains the name of the network card that has an access to the internet on our own system. We'll see it in a second, how to configure it. And later on, we will configure the subnet, the range of the IP addresses that we will want to give to the pods and the gateway. So let's do this with opening a new terminal window and now to check our IP address, I'll use the ifconfig command, which is not installed, obviously. So we'll quickly install it. I'm using ifconfig because it gives us all the detailed information that I will need in a in a very readable manner. So let's just use ifconfig once again. And now we can see we've got a few network cards. First one is a Docker. Docker, when installed, it creates its own network card for the communication between the containers. And right below, as you can see, we've got the ENP0S3 and ENP0S8 card. We are interested in this ENP0S3. Why we are interested in this one? Because this is a network card that was defined in the VirtualBox as the one that has an access to the internet. From the IP addresses in the ENP0S8, you can see that this has an